Hey there, it's Jason from Codemanship with another video diary entry. If you're enjoying these videos or finding them useful or amusing, then ring the bell for notifications and don't forget to subscribe and like this video. Okay, so I want to talk some more about inner loop agility. It's kind of my hot topic at the moment. And in particular, I want to talk about how relatively small delays in processing items in a queue can lead to very long queues. And one of the most powerful examples we've seen of that recently is with the queues that often form in Kent as lorry drivers from the UK are trying to deliver goods to the continent. Now that we've left the customs union, that means that there are extra customs checks for every driver. And even though those extra checks might only add a few minutes to processing each lorry, each driver, those few minutes can add up to massive tailbacks, miles and miles. And we've seen in the last year how, well, certainly since we left at the end of the transition period, drivers being stuck in tailbacks for days on end, and having to suffer all kinds of indignities, having to pee into bottles and all kinds of things because we just weren't prepared. But those extra few minutes processing each driver added up to huge delays. And this is a well-understood effect in queuing theory and a well-understood network effect. And it applies also to software development, which is really what inner loop agility is all about. And that's what I'm going to demonstrate here with a little code example. So as always, this presentation is not aimed at non-technical people. But I've rigged up a little program here. And what this program is doing on this main thread here, it's a little command line application. There's two threads, and on the main thread, I'll just scroll down here, it puts features onto a queue, which I've called the backlog. So it's putting features on a backlog, and it does that every 10 milliseconds. It does it 100 times. Let's imagine that 10 milliseconds equals 1 day. 1 day, okay? We'll come back to that later. So every day, our customer puts a new feature on the backlog, and that's happening on the main thread, the customer thread. We have a second thread, as you'll see here, which I've called dev. And what dev does is every 10 milliseconds, in other words, once a day, dev takes an item, a feature off the backlog and completes it. Okay, and then it adds the completed feature to a list of all the features they've completed. Okay. Now, each feature remembers when it was created, when it was added to the backlog, and it also can be told when it's been completed, and it will remember when it was completed, and it can calculate its lead time. How many milliseconds did it take to complete that feature in total? In other words, how much time did it spend on the backlog? Okay, so we've got two threads, customer and dev. Customer puts features on the backlog. Dev, every 10 milliseconds, every day, takes a feature off the backlog and completes it. And then at the end, when they're all done, when all the features are done and they're all on the completed list, we calculate the average lead time for each of those features. In other words, how much time did they spend on average on the backlog? And then it prints that out at the end. Okay, so let's run this program and see. Remember, 10 milliseconds is 1 day. So with a dev time of 1 day per feature, what does the average lead time, the amount of time it spends on the backlog, look like? Let's take a look, shall we? Okay, off it goes, crunch, crunch, crunch. That's not bad at all, 6 milliseconds. That was rather fast. I think that's because my computer wasn't doing much. Let's do maybe one or two more, 8 milliseconds. And let's do one more, 14 minutes. Now, if it's less than 10 milliseconds, that's slightly suspicious. That's slightly suspicious. Yeah, I think that's a bit more realistic. Around 15 or 20 milliseconds. So a day and a half to 2 days. Let's call it a day and a half. So at the moment, the lead time, the amount of time in total that it takes to complete a feature is a day and a half with a dev time of 1 day. Now, here's the thing. If we were to increase the developer time by just 10%, increase the developer time, Now, this might be counterintuitive to a lot of developers, because very often developers, when you talk about delivery lead times, they're thinking about the time it takes from when they pick up, say, a user story or a feature request to the time it gets into production. That's what they're thinking of. And that's this delay here, basically. That's often what they have visibility of. What they don't have visibility of is the feature lead time. How long is it taking from the feature being added to the backlog to it actually getting into production? And that's the number that we should be really interested in. That's the number the customer cares about, because that tells us how long they would have to wait to get what they asked for. So we've made a 10% increase to the developer time. So it's no longer a day, it's a day and a bit, maybe a day and an hour. Okay, so a small delay. Let's see what this small delay does to the lead time. Okay, off it goes. Wow, 81 milliseconds. Let's do another one. Oh, that's pretty dead on, isn't it? We've gone from a day and a half lead time to 8 days lead time, over considerably more than a week. If it's a 5-day week, that's a week and a half of development. From a 10% increase in the dev cycle time, in that inner loop, just from a 10% increase. Let's make it 20%. Just a 20, so it's no longer a day, it's a day and a bit of a morning. Day and a half a morning, let's say. Oh, okay, that's in the same ballpark. That is interesting. Let's do another one and see what that does. 95, so it's definitely going up. We'll do one more. 76. Interesting. This is, by the way, multi-threading is not by no means a deterministic game. So we're going to get some shenanigans here if my computer's busy or doing other stuff. But let's keep going. Let's create a 30% increase. So maybe that's a day and 2.5 hours. Okay, let's see what that does. Just a 30% increase in the dev time. Okay, so we're getting up into the ballpark of around 13 days, 2 weeks. Well, that's more than 2 weeks. That's 2.5 weeks. Maybe getting towards 3 weeks. 3 weeks of developer time based on a 5-day week. So from a day and a half to maybe 2.5 to 3 weeks, from a 30% increase in the dev cycle time. So small delays can cause long queues. They can create great latency within the system and cause big overall delays. Small delays in those inner loops, which is why inner loop agility, as far as I'm concerned, is the most important form of agility. Again, I'm not saying the rest of it is not important. I'm not saying the customer doesn't matter. I'm not saying that planning's not important, although you shouldn't plan too far in advance. I'm not saying that any of that stuff doesn't matter. What I'm saying is, what makes the biggest difference to overall responsiveness of a team is the speed of that inner loop. Small delays can cause long queues, and that means your customer's going to end up, sitting in a tailback, peeing into a bottle for a long time, waiting for their needs to be satisfied. So that's really what inner loop agility is all about. I will stick this code just for jolly. I'll stick this code on GitHub so you can have a play with it if you wish, or maybe come up with your own versions of this, just in case you think I'm cheating, which I am not. That's really genuinely happening. Those times are genuinely real. And you will see this effect everywhere. And you can probably measure it in your own organization. If you're collecting information, say if you use Jira, God help you, if you're collecting information about cycle times, how long, for example, features take from when they're picked up by the developers to when they're in production, and overall cycle times, those lead times, those long lead times, you can maybe build your own little graphs if you've got enough of a product portfolio to work from. And also see what happens if you measure those lead times, if you plot them against your build and test cycles, because build and test is the innermost loop. That tends to be the thing that makes development cycles slower. So you're in the same way that your development cycles can have a profound effect on the overall lead times. The inner loops of the developer cycles, in particular, how long it takes to build and test the software, can have a similarly profound effect on your developer cycles, your overall developer cycles, getting features into production. It's all wheels within wheels, basically. So there you go. Small delays, long queues, and that's what inner loop agility is all about. Take care until the next video.